Hi guys, my name is Mercedes and I'm helping out Mrs. Merriam by making a few of these lectures for you. And so today we're going to be going over dimensional analysis. So dimensional analysis seems kind of intimidating to begin with because of all of the conversions and there's quite a bit of math involved, but it's really not. So starting off with this picture, imagine that you're looking down a road and you're thinking, how many miles is this? Well, you don't necessarily have to only think of it in miles. You can think of it in feet, you can think of it in yards, you could even think of it in meters, centimeters, millimeters, so on and so forth. And if we were to say that we're looking at a mile worth of road, then we would be able to put a specific value to this. And this is where using conversion factors comes in. So a conversion factor is a number that is specific to a unit, and it actually signifies that this is equal to another value for another unit. So for instance, you have 1 mile, and this is equal to 5,280 feet. That is a single conversion factor because you're saying that there are 5,280 feet into this 1 mile, vice versa. And it's essentially equating the two measurements so that you can move in between them. And this is true for yards, which is 1,760 yards in a mile. There's 3 feet in a yard, 12 inches in 1 foot. These are all examples of conversion factors that we use in the standard system. Now, since the metric system is commonly used in chemistry and other sciences, you have to be able to convert in this one too. And I think this is a little bit easier, but it's all up to personal preference. The metric system works in sets of 10. It works in multiples of 10. And so say we're working in meters, also a measurement of distance, and we have 1 meter. This means that if we wanted to know what this was in centimeters, we know that there are 100 centimeters in 1 meter. That in itself is a conversion factor. If we had something like 2 meters, we could just multiply by whatever we need by that 100 to get us into centimeters. And this is true as we go up and as we go down. So anytime that we have 1 meter and we want to say this 1 meter is equal to this, then we're going to multiply by factors of 10 going down to say it equals centimeters or millimeters and so forth. If we're going up and we're getting into larger units, it makes sense that we're going to divide by factors of 10 to show the fact that it remains the same size, but it's being measured with a larger measurement. Sometimes it's really hard to visualize this. So I like to think of it in terms of a ruler and looking to see how they kind of equate. So when you know that there's 2.54 centimeters in an inch, you can actually look at the ruler and look at that around 2.5 centimeters. That's where the inch mark is. There is a correlation between these values, and it's not just some arbitrary way that we have linked conversion factors together. It actually makes sense when you apply this to measurement because these numbers aren't just numbers, they stand for something more. So knowing that, we can start to apply it a little bit. So we'll start off easy with just converting in standard measurements. So we want to convert 654 feet into miles. So the easiest way that I know to do this is using a bracket system. This is how I learned. You can figure out whatever method works for you, whether that be using fractions or whatever, but this seems to be the simplest and the least confusing way to do it. So what you do is you start with the measurement that you're given or that you found for yourself. So in this case, it's 654 feet. And so we create our bracket. In order to go between units, we have to cancel them out. In order to do cancellation here, we're going to have to divide by feet to get into miles. So we know that there's 5,280 feet in 1 mile. We can use that here. And so we're going to divide by 5,280 feet. And this equals 1 mile. Put that on top. The units cancel. And this gives us 0.12386 miles. But It doesn't, because significant figures always applies. So if you have your original answer, you can go ahead and shorten it or whatever you have to do to get it down to sig figs. So we started with 3 significant figures. The conversion factor does not matter at all when you're dealing with sig figs. And because of this, we know that our final answer is going to be 0.124 miles. Moving on, now we're going to convert in between standard measurements and metric measurements. And you have these conversion factors in your notebook that Mrs. Merriam has provided you, and they'll be of great use later on. So here we can use that to our advantage, and we'll start with our 6.5 inches. We're going to create our bracket, and we know that 1 inch is equal to 2.54 centimeters. So we're going to multiply across 6.5 times 2.54, divide by 1. Our units cancel. And we're going to be left with 16.51 centimeters. When we apply sig figs, we actually round up to 17 centimeters for a final answer. Making this a little bit more difficult now, we have to add in more steps, because later on you're going to find that doing dimensional analysis is not simply a one-step matter. You have to take stepping stones in the middle of your dimensional analysis to get from one place to another. You can't necessarily make that in one jump. So in this problem, you could make it in one jump, but I'm going to show you how to do it in multiple. So we start with our 65 millimeters here. And this is where it comes in knowing how to convert in between the different metric units and from metric to standard. So we know that there are 10 millimeters in 1 centimeter. And we also know that there are 2.54 centimeters in 1 inch. Knowing that, we can multiply across. Our units cancel in both places. And we end up getting 2.559 inches, which, applying our limit of 2 significant figures, means we have 2.6 inches for a final answer. Now, there are other ways to go about doing this. You could have just automatically gone from millimeters into inches and known that there are 25.4 millimeters per inch, since you know there's 2.54 centimeters per inch, which would be fine. It would shorten the amount of writing that you have to do in the page, certainly, but if you ever need to keep track of your individual steps, this is probably the best way to go about doing it. So moving on to the next problem, now we want to know how many seconds are in 5 days. This is a problem where we're going to have multiple steps. You could shorten those, or you could just do them in the elongated form. It doesn't really matter. So we'll start with our 5 days. And then we're going to say that that 1 day is 24 hours. And we know that 1 hour is 60 minutes, and that 1 minute has 60 seconds. Our units cancel all the way across. And we're going to go ahead and multiply across and then divide. So it's 5 times 24 times 60 divided by 1, which gives us 432,000 seconds. When we apply significant digits, we only are allotted 1 significant digit. And here we can write this in multiple ways. So you could write 400,000 all the way out, or you could write this as 4 times 10 to the 5th seconds. Either answer is fine. It means the same thing. Just one is in scientific notation. So now the concept of volume is a little bit interesting, because you can actually take distance measurements, and when you make area or you cube them, you get into the realm of volume. So say we have a little cube here. Pardon my drawing skills. And this cube is 1 centimeter high by 1 centimeter long, and it's 1 centimeter wide. If we want to know its volume, we're just going to go 1 centimeter times 1 centimeter times 1 centimeter, which equals 1 centimeter cubed. We know this. But to make this a little bit more interesting, now let's talk about how this connects to the concept of liters, which is the actual measurement that you can do for volume. If we have like a liquid or something that we want to be able to take volume measurement of like that, we can do that. You can also use displacement to find the measurement of solid objects using liters. But either way, this 1 centimeter cubed is actually the same as if we took a graduated cylinder like this, and if we had 1 milliliter of fluid, because 1 centimeter cubed is the equivalent of 1 milliliter. Knowing that, anything that is measured in centimeters cubed can be converted into milliliters and then into liters from there. There's also other ways to convert in between these, but it requires a little bit more math to accomplish it. So with this next problem, we'll start again with our given measurement of 550 centimeters cubed. And we know that we want to get into liters. So knowing this equivalency above, this conversion factor, we're going to say that 1 centimeter cubed is equal to 1 milliliter. And then we know that there are 1,000 milliliters in 1 liter. Hence the term milli. Milli means 1,000 into the 1 liter. We're going to multiply across. All of our units will cancel. And so we end up with 0.55 liters. Now, we started with 2 significant digits, and we have ended with 2 significant digits, so we don't need to worry about changing our answer at all. This is our final answer. So finally, in this last problem, this is where it gets a little bit interesting. We want to know how many meters cubed there are in 564.6 centimeters cubed. This is a little bit of a different concept. You can't just go and say there are 100 centimeters in a meter. While that is true, there are not 100 centimeters cubed in 1 meter cubed for this reason. So imagine we have our cube again. And it's 1 centimeter tall by 1 centimeter long by 1 centimeter wide, and it's 1 centimeter cubed in volume. This value is 1 times 1 times 1. Now, if we were to do this in meters, 1 meter cubed is a giant cube. It's not related to that smaller cube in any other shape here. We know that it's 1 meter tall by 1 meter long by 1 meter wide. So keeping in that idea that 1 centimeter equals 1 meter, we can actually figure out what a conversion factor would be for this. They can be given to you, you can figure them out themselves, but when you're working through them, you have to understand that there are actually much less cubic centimeters in a cubic meter than you would originally anticipate. So this is how this works. We want to be able to make them equal. So if we have, say, we only have 1 centimeter, this is actually equal in meters to 0.01 meters. So knowing this, we can say that 1 centimeter cubed is equal to 0.01 meters times 0.01 meters times 0.01 meters. So 1 centimeter cubed is equal to 1.0 times 10 to the negative 6th meters cubed. It's a way smaller number than you would originally assume. Knowing this, we can accomplish this problem now. So there are 564.6 centimeters cubed in whatever object we just measured volume on. And we know that 1 centimeter cubed is equal to 1.0 times 10 to the negative 6th meters cubed. Multiply across, our units will cancel, and we end up with a ridiculously small number. We get 5.646 times 10 to the negative 4th meters cubed. Now we look back, we started with 4 significant digits and we ended with 4 significant digits. So this is our final answer. And so to finish this off, there are a few tricks that you will eventually figure out how to use with dimensional analysis. So for instance, back here, when we were talking about these, our prefixes and how these relate to one another, you'll realize that all this is moving along here is a movement of the decimal place. So if you know that you're going to be moving by a factor of 10 and you're going from 1 meter into a decimeter, you know that you can start with 1 meter. And since your decimal place is right here, you're going to move it over 1 digit to show you're multiplying by a factor of 10 so that you end up getting 10 meters. Not meters. You want this to be in decimeters. Pardon that. And this is true for any of the measurement values. You do the same thing for centimeters, millimeters, micrometers, nanometers, picometers, all the way down. And then going up, if you start again with this 1 meter, but you want to take it into like, per se, kilometers, you're going to end up moving the decimal point that's right here this way to show that you're dividing. And you're going to divide by 1,000. So your decimal place is actually going to be right here. You're going to add your zeros, so you get 0.001 kilometers in 1 meter. And it's simply a visual way to see that you are multiplying by factors of 10, but all you need to do is move the decimal place. If it's easier at first to just write out the math problem and say, okay, I'm starting in meters, I need to go into decameters, I'm going to divide by a factor of 10, you just divide by 10, and voila, you'll end up with your appropriate value. And you can just use the conversion factors that way. But when you're working in the metric system, it's honestly easiest to get to the point where you can just move the decimal around. And that is about all I have. If you have any questions, Mrs. Merriam will answer them for you. And I hope that this was informative and that this helped you some. And I hope you guys have a great day. Thank you.